Hello NCU students, welcome to week 4. I hope you're doing well. I know this is a humdinger of a course, meaning it's taking an extraordinary amount of work. And listen, I know this is hard, and sometimes the hardest thing in this course is the mystery of figuring out which formula to use for a given problem or a case study. So in this week's overview, I'm going to try to unravel that mystery a little bit and hit the highlights of what we're studying to help you know which formulas to connect to which case studies and that sort of thing. Now, just let me note one thing here before I get into the learning outcomes for this week, that we are working in Chapter 6 again. We're going to do a little bit of review there. We're going to learn some new things in Chapter 7, and we're going to hit just a couple of new sections out of Chapter 8. Now, I know that Chapter 8 reading is not on your syllabus for week 4. It's not until week 5. But you're going to need some of the information from that chapter, Chapter 8, to complete the case study number 7, which is this week. Now, the quiz for Chapter 8, it's still in next week's material, but the reading is for this week. So maybe look at this as a way to get a little bit of a head into next week, so next week's workload won't be quite as bad. This week we're reviewing a number of topics, and here's what we're looking at. We're going to be reviewing sampling errors and confidence intervals, again, from Chapter 6, and this will be Section 6.2. We're going to be looking at establishing confidence intervals and population means using that t-distribution. That's also out of Section 6.3. That's from last week as well. We're going to be learning some new things about null and hypothesis testing, and you may have run across this, probably have in other stats course, so this may be a review for some of you. Also from Chapter 7, decision-making risks and the errors that go with it, Type 1, Type 2 errors, that sort of thing. We're going to be looking at hypothesis testing and the issues that go with that. We're going to look at things like using F-critical or p-value as the boundaries between accepting and rejecting the null. And then we're going to use the t-test to evaluate the differences between the means of two independent groups, and the t-test as a paired t-test, where it's going to be between two groups that are dependent upon each other. And that's out of Section 8.3. Now, this week we're going to go back, like I said, and revisit a couple of topics in Chapter 6 before moving on to Chapter 7 and then into 8. And the idea of sampling and sampling errors is critical to understanding statistics. In fact, if you jump back to Beacon Learning in Chapter 3, there's some things you can review in the Attend section about Chapter 6 that might help you. And then take a look at some of the new material in this week's Attend section as well, related to Chapter 6. One of the big principles to review from Chapter 6 is that we often do not have enough data to calculate the population's mean or the population's standard deviation, but yet we need to make decisions about that population, and you can't proceed unless you have some data. So we sample the population and estimate our confidence in those samples to better understand the population before making some decisions. That's a key concept to remember when you take on case study number 6 this week. From Chapter 7, we are learning about the concept of hypothesis testing. Specifically, we are learning about the null and alternative hypothesis testing model. This type of testing allows us to establish hypotheses about the entire population and then use sample data to accept or reject our hypothesis. So, the entire notion of this testing model is built around learning about the population by using some sample data. And think about this in the form of set theory for a moment, if you will. Just so look at the screen in front of you. The null hypothesis expresses what we would call the status quo, or the current situation. It's the situation we believe is happening, so we assume the situation is correct by default. All other hypotheses, alternatives for example, are outside of the null hypothesis set, and those are called the alternative hypotheses. It's the opposite of the current situation. Those alternative hypotheses, there's the opposite of what we believe is actually happening, and most time it represents what we want to prove. In essence, we set up the model to de facto accept the null hypothesis and then let the statistics show that it's not true or that it's not happening the way we think it is. So if the statistical evidence points us away from the null hypothesis, we reject the null hypothesis as happening, and therefore we must accept the alternative hypothesis as correct. Let's talk about the statistical evidence for a moment that we use. In hypothesis testing, we have a test statistic. That's a phrase you're going to hear a lot. If you haven't read it already, you're going to hear a lot of it. So we have a test statistic that helps us determine if we should accept or reject the null hypothesis. The test statistic is a number. It's derived from an equation. And check out some of the ones that are mentioned here on the screen. There's the z-stat. That's the test statistic testing the differences in two proportions. It uses the z-statistic. You can find that on page 154 in our text. How about this? The t-value can be used two different ways, or multiple ways actually. But one of the ways is the value t is a test statistic testing the differences between two means with independent groups that don't have any relationship to each other. Well, what's the difference between those means? Is there a relationship? The t-test statistic will help you figure that out. Or how about this one? The value of t is also a test statistic testing the differences between paired means with independent groups. More about that on page 165 in our text. And what about this one? Here's another test statistic that we haven't even run up against yet and probably won't for another week or so. The value of f, capital F. It's a test statistic that's used in models like what we're talking about called one-way analysis of variances, or ANOVA. Then we're going to study about that in chapter 9. So that term test statistic is different based on what specific statistical tests we're going to be using. Now, there are two methods for using the test statistic to determine if we should accept or reject the hypothesis. Method 1, the hypothesis testing uses what's called critical values as the boundary for the test statistic. Sometimes this is called the traditional approach. There's a video I've got out there where the person who puts the video together talks about this as the traditional approach, where we're using critical values to accept or reject the null hypothesis. Method 2, the hypothesis testing uses what's called the p-value as the boundary for the test statistic. Sometimes it's called the non-traditional approach, but it's very popular among statisticians. It's actually a little bit easier to talk about. Let's look for a moment at method 1, which is hypothesis testing using critical values as the boundary for that test statistic. From the chart that you have in front of you, you can see the critical value is usually given in some form in the problem, and it may have to be converted to a normalized value from a z-table or a t-distribution table or something similar like that. But it's called the critical value. And it'll be it'll be on that bottom x line. It'll look very much like a z-value of like 1.5, 1.96, 2.2, 2.25, and that sort of thing. It becomes the fixed point on the graph as the boundary between accepting and rejecting the null. Now, I've attached some videos that I found that I think are helpful, and Dr. Veach has a PDF file as well talking more about this critical value and how to calculate it and that sort of thing. And in this model, if the test statistic is above the critical value, you reject the null. If it's below the critical value, you have to accept the null. Let's look at method 2, which is using the p-value as the boundary for that test statistic. Now remember, when we're using probability density functions, the area under the curve is the probability, and it can't be greater than 1. It can't be greater than 100%. So when the probability for the test statistic is small, really small, then the probability of the critical value, when the test statistic is smaller than the probability of that critical value, then it's very improbable that we'll ever see that test statistic happening, and so we reject the null. In other words, there's another chart here trying to explain it a little bit differently. The area under the curve, that goes with that test statistic, or x on that chart, when it's smaller than the area under the curve for the critical value, which we usually derive from what's called the alpha level, then we would reject the null. Now, the alpha level is often expressed as 95% confidence, 99% confidence, 90% confidence, and that sort of thing. Okay, chapter 7 also discusses the different types of mistakes that we often make when we evaluate the null hypothesis. Now, be sure to read about these type 1 and type 2 errors. They're in section 7.3 in your text. The case study number 7 uses two different test statistics for the t-distribution to get that done. or for you to get the case study 7 done, you have to understand these two different test statistics that are used in these two different calculations. Question 1C and 1D, they use a test statistic for the t-distribution to measure the variance, the difference, between two different groups that are independent of each other. Now, this is called the pooled variance t-test for independent groups, and you can find it in section 8.2, and I've also included a video lesson that I found as well that I think will go with that. Question 2C uses a test statistic for the t-distribution to measure the variance between matched dependent groups, and this is called the paired t-test, and you can find it in section 8.3. And again, I found some supplemental videos that will help explain the concept. Okay, that's it for now. Remember to start thinking about your business data analysis project. Consider a simple but effective project where you work. Make it usable to you. A little bit more to come on this, but listen, check out the syllabus. There's a lot of information about that. The primer, the first draft, if you will, is due in week 5. Not the entire paper, just what we're calling the primer. Again, that's in your syllabus. Check that out. My virtual office hours, again, we changed them to Wednesday evenings to give both you and me a little more time to put the homework assignments together to make sure I'm telling you correctly. Wednesday evening, 7 p.m. Pacific time. I'm also available at other times if you want to meet up for a quick question via Zoom. Send me an email, send me a text. You've got my phone number. I might be able to drop what I'm doing and jump in and help you. There are 2 case studies assigned this week, but guess what? You only need to do one of them. Pick one and complete that assignment and leave the other one blank. Dr. Deach and I will figure out how to handle the missing grade later on. We wanted to give you a bit of a break, though, as we head into the second half of this course, because we know that this is difficult material. So we want you to enjoy the moment and not worry about one of those case studies this week. Pick the one you want to do, get it done, and make sure you submit it in Beacon Learning. Leave the other one blank. Remember, God invented numbers and statistics, and He gave us the ability to learn this part of His creation. So don't give up hope. Even though you get frustrated, listen, I get frustrated with some of this stuff too. Ask Him for guidance and understanding like I do each and every day. Listen, He is on His throne. He's always been there, and He's always going to be. Have a great and wonderful day.